Hello, everyone. So, thank you for joining and welcome to the Webswing webinar about Webswing 24.1 release. I got some votes to submit. Okay, so let me welcome my colleagues here. It is Victor Messaros here, who is the founder of Webswing. He's doing Webswing since 2012. And he will be presenting to you as well our most senior developer, Branislav, who is with Webswing for, I don't know, 6-7 years now. And he's the core architect of the new features, which we'll be presenting. And myself, I'm just the host who is for licensing and sales here. What are we going to talk about? We are going to talk about the new features in the 24.1 version of Webswing. We will show you some updates regarding modernization. This is something what we released already in the version 23.2, but now we went much further, much deeper with the integration, with the implementation. It's already integrated with some of our customers. So we got a lot of customer feedback, etc. And then we want to talk about instant title sessions, how it works, showing you demo. What are our plans for the future? And on the end, we are happy to hear your questions and happy to answer those. So I will now hand over the word to Branislav. And thank you again, everybody, for joining this webinar.
Actually, Victor.
Victor,
hey
okay.
Yes.
My bad. I understand it's you. Okay. So,
No,
Victor. But I cannot see you, Victor, so that's why.
Oh, sorry. I forgot to turn on camera. Is it better now?
Much better. Much better.
Oh, okay, cool. So, hi. Welcome, everyone, to our first webinar this year. And I'm happy to show you what is new in the new version 24.1. So we have, let's say, 5 new things that we managed to squeeze into this release that are worth mentioning in this webinar. I'll briefly describe the first 4, and then Branislav will give you a deep dive into the 5th one, which is the instant title sessions, as Igor mentioned. And he will show also a small demo. So as the first feature, as you all know, Java released the new LTS version 21. This is old news. It was back in September, but as our release plan dictates, we always release our support for the given LTS version of Java with one major release delay, which tend to be the 24.1. So in this release, we introduced this 21 version Java support. We initially designed our release plan to be more synchronized with the LTS releases of Java. But as it turns out, the Java releases are not very predictable. So therefore, our LTS release, which was the 23.2, is a bit out of sync with the Java release. But don't worry, we decided to merge everything that you see on this slide back to 23.2, I think starting with the 0.7 release as well. So all you can see on this slide applies to the 23.2 LTS release. So in addition to the 21 Java support, we also added the Java FX support. So far, before this release, we only had a single toolkit implementation that supported Java FX version 8 and 11. But the Java FX 17 had some breaking changes, so we had to add a separate toolkit implementation for 17, and we also did 21. Now it's also possible to switch versions of JavaFX in the configuration, which previously wasn't possible. You always had to use the same version of JavaFX as you used Java, but that's now fixed. And we also do support JavaFX SDKs. which is essentially just a Java release that embeds the JavaFX libraries. But in Webswing configuration, you can just tell that you are using this kind of Java release, and you don't need to supply your JavaFX libraries. So it's like a convenience thing. Okay, the next feature is the file chooser interface. So until now, Webswing's automatic file chooser integration, which is the small toolbar on the bottom right corner when you open the JFile chooser, the built-in JFile chooser class is visible. Webswing can detect that and then show the file chooser integration toolbar where you can upload and download files from your browser to the Swing session or to the Java application session. However, if you have a custom file chooser component, or you have any other use case that requires this kind of file integration where you need to upload or download files without displaying the JFile chooser dialog or displaying the JFile chooser component, it wasn't possible until now. So this is why we decoupled the integration from the JFile chooser class to allow registering essentially any component or any class that implements the Webswing file chooser provider, and with this to work with this kind of automatic file upload download integration. There are essentially two ways you can use this integration. Either you bind the either you implement this Webswing file chooser with an actual Swing component, and in this case, the Webswing will manage the visibility of this integration based on the visibility of the component. So this is similar to the JFile chooser, but you can use custom components, or you can have a global file chooser, which doesn't have to be in the component tree or anything. It doesn't have to be related to Swing. It can run globally, and you can manually control when it's visible, and it gives you the ability to run uploads and download tasks in background without actually blocking the user's activity while these tasks are running. Yep. You can check it out in our Webswing demo. There's a small example for that. Next one, quite significant improvement from my perspective, is our new fast serialization. And this is a feature we use for encoding and decoding binary WebSocket messages. So all the communication within Webswing essentially happens through WebSocket, sending binary messages between admin console, server, instance, and browser. These all four components communicate together with using these messages. So it's kind of a core thing for Webswing. And for a long time now, we were relying on Google's protocol buffers for this job. But in our effort to optimize the performance and the code maintainability and development process, and also from big part, we're trying to decrease our reliance on third-party components. So we decided to try to replace it. And also because we are using a comparably small part of the protocol buffers the features that protocol buffer offers. So it doesn't make much sense for us to ship this whole library if we use only like let's say 30% of it. So in the current version, this serialization is behind a configuration flag, which is by default disabled, and it's still marked as beta, but it's tested so far. It's working quite well. But in the next release, we plan to enable it by default. And in the 25.1, which will be the next LTS release, we plan to completely remove the protobuf library from Webswing and fully move to this new serialization way, if everything goes to the plan. So a little bit details how it works. It's very similar to how protobuf works, where it generates the encoders and decoders for Java and also for TypeScript at compilation time. But we are not using the .proto definition format, but rather we are relying on a plain Java Pojo classes, and based on those, we generate the encoders and decoders. And based on our measurements so far, the generated message size, depending on the message type and message contents, it's between 20 to 50% smaller, especially in direct draw messages where it is most significant from my perspective. Where we also added some custom optimization hints, so the performance is better there, essentially. And also from the speed, it's up to 3 times faster, again depending on the message type. But this being said, I wouldn't expect huge noticeable performance gains, because also the protobuf library was very fast, and it was never the performance bottleneck in Webswing. But I think still it's a pretty nice improvement in the long run. And the last, second to last change that's worth mentioning is the way that we are storing and defining the advanced application settings from this version on. These are the settings that are not directly visible in the configuration because they are not changed very often. And these settings used to be defined in the VM arguments as a system properties, which you can still do in sake of backward compatibility. So you can still, if you already use these in VM arguments, you can leave them there. It will still work. But from now on, there is a dedicated new configuration field where you can specifically define these arguments, and there's a nice drop down where you can see what the argument is for, what type it is, what's the default value, and you can essentially define your own startup parameters for this. And also the change is how these values are now stored in the application. Before we were just relying on the system properties. Now they're rather stored in an internal data structure to prevent pollution of system properties, and so that we can better control the access and mutation of these settings. So even if you initialize these properties from VM arguments, if you need to change them, or if you need to get the effective value for these settings, you will need to use the Webswing API's get or set settings methods to interact with them. There are very few cases where you need to change these parameters, and even less cases where you need to get these parameters. And some of the basic parameters are still exposed as system properties that some third-party products use to detect Webswing, for example. But for the vast majority, they moved to this internal storage, and they no longer pollute the system properties of the application. Yeah, and before we jump to the idle sessions, I wanted to give you a quick update regarding the migration components feature that we discussed on our last webinar. Since then, we have added a couple of additional examples to how we can migrate more complex components to our Webswing demo application. And also we continued our work on the Webswing look and feel package, where we are trying to create web components, web component based rendering for all the built-in Swing components, and just use it as a new look and feel for your application. So far, we have 24 out of 43 components ready. And in addition to that, we have added some examples for JDesktop internal frames and an example how you can easily switch between web and Swing based rendering in runtime. But it's not all just sunshine and roses. When we were working on these more complex components, we essentially realized that we are in dire need for being able to control or at least influence the layout of the application from the web rendering part. But to support this, we need to add some new capabilities to our core rendering in Webswing. Now, because we have two different rendering modes, Webswing PNG rendering and the direct draw rendering, we would need to implement this capability twice. So we decided to first refactor the rendering code to unify these two rendering modes. It's a bit of a rabbit hole we went down. But I think it will lead to a much better and more maintainable code for the long run. And essentially, this refactoring is almost finished now, and we can now move on to keep improving these migration components. Yeah, I think that's all from my perspective. I think now it's time for Branislav's demo and introducing the instant idle sessions.
Yes, thank you, Victor. Hello, everyone. Let me first share my screen. Okay. So I will tell you something about idle sessions. So some of you already know what idle sessions are because some of you are already using it in production. For those that don't know, idle instances feature allows you to basically have a number of pre-started JVMs waiting in the session pool for the user to connect to it. So the value added here is that the user will wait less time from the time he accesses the URL until he sees the first render. So I have prepared 4 use cases or configurations that I will show you, and I will explain how it works. So the first one is no idle. So this is when you don't have any idle instances configured. So basically how this works is that user connects to the browser, requests an instance from Websync server, and Websync server requests the instance from session pool. It doesn't matter if you have cluster or standalone Websync, it both have session pool. And this session pool starts a new JVM. This JVM is not directly the application main, but it's first our Webswing main and some bootstrapping stuff. And then we call the application main, which then connects to the Websync server and starts basically rendering. So this whole process, the user needs to wait until he gets the first render. I will now show you our demo application code. So here we have the idle demo main class. In this main class, we will have some kind of task we need to do before the application starts to render. It can be preparing the backend, connecting to a database, or just loading some Java library. In our case, we will just sleep for 3 seconds, and then we will make the JFrame visible. So let's see how this works in action. We can check the configuration. We don't have any idle instances configured. And here we will start the demo application. So I will refresh the page. And now you can see the time to first render took 5.5 seconds. So if I do it again, let's see, it will be again about 5 seconds. So this is from the time that the JavaScript starts loading until I get the first visible frame. So it's about 5.5 seconds. Okay, so let's see if we can make this faster. So the next configuration is basic idle. This we have introduced in version 23.1, so you may have already used it. In this case, inside session pool, there is this idle service. This idle service just starts the pre-configured number of idle instances. And what does it mean to start an idle instance? Basically, it starts the JVM, and inside the JVM, it only starts this orange part, so only the Webswing stuff. This is where it stops. And when user connects through the browser and requests the instance from session pool will tell the idle instance to start the application main. So here we will wait until it starts, and then it will connect to Webswing server and starts rendering. So again, let's we don't have to see the code, but what we need to do is configure this. So it's very simple. We just change the number here, and we will tell Webswing we want to have 3 idle instances. So once we save the config, we can go here and see that the idle instances are being created. So every 5 seconds there is a new idle instance until there are 3. And now we can go here and see if this improves our time to first render time. Okay, so now it's 4.7 seconds. Let me start another one. And you can see in the instance ID, it says idle, because when this instance ID is created, we don't really have the username to use here in the instance. So we use idle. So this is about 1 second improvement. This is probably the time that the JVM takes to start on my computer. So it's a bit of an improvement, but let's see if we can do some more. So what we introduced in 24.1 is pre-launch, and pre-launch is basically a stage somewhere between the start of the JVM and the full launch of the instance with the user. So here the idle service starts the JVM, and when it starts our Webswing main and the bootstrapping stuff, it also starts another class or main class which we configure. So this is user specific or client specific class, and we call it idle demo pre-launch. And here in this class, you can do whatever task you need to do to prepare the application for the launch. So if you need to initialize the backend or connect to the database or load some library, you can do it here, and it will be prepared in the idle instance when the user connects. So when the user requests the instance from the session pool, it will only start the application main, and then connect to the server. So I will show you how it looks like in the code. So here in the code, what I can do now, I can comment this prepare backend. So we are not going to do this in this application, in this app main, because we are going to have the backend prepared already. We are going to implement this idle demo pre-launch class, which extends Webswing pre-launch class, which is provided by Webswing in the API. Here we override this pre-launch method. We can also send some arguments from the configuration. And here we do the prepare backend. So it's the same, it's thread sleep 3000 milliseconds. And when this task is done, we also need to notify Webswing that we are done and the instance is ready to be used with the user. So when this happens, the idle instance will be ready to be connected with the user. So I will just rebuild this demo because I changed the code. And while it's rebuilding, I will show you how to configure this. So in the configuration, we have a new field which is called pre-launch. Right now it's set to none. Now we will use this custom option. So in custom option, the two new fields appear. This is the pre-launch main class, which I showed you. It's the idle demo pre-launch, and we can also use some arguments if we need to. So now when we save this, we will have 3 idle instances running, which also ran this idle demo pre-launch. So they're already created. Okay, now let's check the time. Okay, so now it's 2.1 seconds, which is almost half the time. So that's pretty good. Cool. Okay, but let's see if we can make it even faster. So I will show you the 4th configuration. Okay, the last configuration is instant idle. And instant idle means that the idle service, when starting the idle JVM, will fully start the instance. So there's no pre-launch class. It will basically, after the Webswing main, it will start the application main. So in this case, you need to think about how this will affect the server, because the whole application will be fully loaded and take full resources in the session pool and basically just doing nothing, waiting for the user. So when the user connects and requests an instance from session pool only finds the idle instance and tells the application to connect and render. So it doesn't have to really wait for anything else than creating some WebSockets. Okay, so let's see it in action. What we have to do is we have to bring back this prepare backend because we won't be using the pre-launch. And what I want to talk about is also this invoked when launched callback. This is a callback we have implemented in the Webswing API. And this is important because if you have this main running in idle or running in not idle mode, you don't know here, you don't know where you are. In your code, you don't know if you are running in as idle in the without user, and you are just waiting for the user, or you are being fully launched and it will be available for the user. So to save some resources, you can use this callback, and this will be called only when the instance transitions from the idle state to the full state, waiting or expecting the user to be connected in a few milliseconds. So this is where you can, for example, what we do here is we make the JFrame visible. So until the user needs the instance, the UI is not visible, and you can just postpone anything you need to postpone into this callback until you have the user. So you can save some resources by this. Okay, so I will again rebuild because we changed the code. And okay, here in the configuration, we are going to change this from custom to main class. And what main class means that in the pre-launch stage, we are going to launch this idle demo, like main app main. So that's basically all we need to do. We still will have 3 idle instances. Okay, let's wait for them to spin up. A few moments. Okay, and let's see how fast it can be. Okay, so it's 1.2 seconds. So that's pretty fast. Before, when I was not running this webinar, it was like 900 milliseconds, but it really depends on what is running on your machine or how much resources do you have. So, but basically it doesn't get really much faster than loading the JavaScript inside this page, then creating and connecting the WebSocket to the server, and connecting a WebSocket from the application to the server. So the WebSocket could take from 3 to 400 milliseconds. So you can double that, and it's like the minimum you can get from the idle instances. So there's this kind of limit for where you can go, but I think it's pretty good to go from 5.5 seconds to 1.1 or 1.2 seconds. And there are also some limitations to this approach, because when the user connects here, the idle instance is already launched, so you don't have you cannot have any user context here when your idle demo main is starting. So you cannot really rely on some variables in the configuration that come from the user, like locale or time zone or custom arguments you put inside the URL. So, but there are some other configuration options that you can use to push the properties to your application. But you have to be aware of this, that it's not like just changing the configuration, but you need to take care of this. Okay. You can find some more information in our documentation about this. I think that's about it. Okay, Victor.
Yeah, I'm here. So where is the? Okay, here it is. This was your part, and yeah, okay. So if you're asking what you can expect in the upcoming release, as I already mentioned, the unifying of PNG and direct draw rendering logic. This was our main focus in this cycle. This is kind of just an internal refactoring that really won't affect the functionality or the core concept of PNG or direct draw rendering. PNG is still going to be rasterized on the server and be sending already rendered images to the browser, and direct draw will keep sending vector graphics to the browser. It only means that we won't have two different paths for handling the web component integration and combining the web parts with the Swing parts in the logic. And So this is, like I mentioned already, 95% done. So we are now going to be focusing on the layout control from the web, and then continuing the modernization or the component migration framework and improvements in that area. Also, we have been working on the test tool to improve the capabilities in the web testing. That will be important, or is important, after you have this component migration deployed, because you will need to be able to test this migrated component as well. And one other thing that we have been working on is the XVFB mock. It's just a working name so far, but it is to replace the XVFB run, X server virtual buffer, that is necessary for running Webswing on a headless Linux, because Swing has some native dependencies on X server, and it essentially doesn't use anything from the web server, from the X server, but it needs to have it available and running just in order to start. So we are essentially creating a small tool that will be able to replace this XVFB. And this is essentially because some of the new Linux repositories started to remove this package from their package manager. So this is like our another way to remove another third-party reliable we don't want to be we don't want to rely on any third-party libraries. So so this will be in the 24.2. Yeah, I think that's all from me. So in case you have any questions, I see a couple of them in the
we have several
in the queue. So if there is nothing else from you, Branislav or Igor, we can start answering them.
Yep.
Not for me.
Okay. So let's start with the first question in the queue. The X11 is being deprecated fast from Linux. It already has deprecated status in Red Hat Enterprise Linux 9. Any plans to replacing XVFB with Valent alternative? Yeah, I already mentioned we will be, because Swing doesn't really require not Swing, Webswing. When running Swing on Webswing, it doesn't really require any services from the XVFB. We can create like a limited subset and just satisfy Swing to run, and we will have this small tool that will replace the XVFB, and you can start. It will be essentially integrated in Webswing and won't need any third party. I hope that answers the question. Let's continue. Will XVFB mock be 100% in 24.2?
That's a challenge.
We can send you what is it? A snapshot build. We can send you a snapshot build so you can try it out yourself. We already have a working version. It's still under testing, but if you want to help us testing, we can send it out to you. Just send us an email to support at Websync.
Yeah, if there is, Victor, just a second. If you have any questions, then please write us a question at support@webswing.org, or you can also contact us via our webpage. So if we didn't answer everything, we are happy to schedule a separate call and answer for your specific use case anything any questions you may have.
Okay, next one. Can I ask questions orally? I don't think this this live storm allows that. But if you have any questions and you want to discuss with us, just send us email. We can schedule a call and we'll answer any of your questions. Next one. So if you have one idle instance configured and one user connects to Webswing and uses up all the idle instance, will Webswing load another idle session in preparation for another user? Yes, but Branislav, you can.
Yes, I mean the answer is yes. The service is always monitoring how many idle instances it needs to start up, and there's like you can configure, like for application 1 you want 2 instances, and for application 2 you want 3 instances, and there may be a limit on the session pool that you want only 2 idle instances together to be on the session pool. So there's not always all of them created, only up until the limit that you set, but it's like round robin, so it always creates one for each that needs to be created. So yeah.
Okay, we can continue to the next one. Could you please provide information for the file chooser dialog changes mentioned in the beginning? Do we have a documentation already for this, Branislav? No?
Yes, I think so. Yes.
So essentially, there is also a demo. So if you have a look, on our prototype, or if you start Webswing locally, in our Webswing demo, maybe we can also show it here.
Do you want me to share my screen and show it?
Yeah, sure. Please do.
The demo, right?
Yes. So the file chooser provider demo.
Yes. So hopefully it will work. There's a custom dialog. Yes. So let's upload something. This is like a custom component, and this is an HTML panel. So you can basically like create a folder, upload a file, download the file, and you can also have this, as Victor mentioned, global file chooser. So if you register this, this is the only file chooser that will be working, and you can basically close it, open it again, and just continue. I think I can show you something like process of download, because it's on my local host, so it will be really fast. But basically it's a seamless integration, and you don't see any, like if you have this file chooser, you don't see this interface here, right here. So it's all like included into the code. Anything else?
Yeah, maybe do we have the source code here in the demo exposed in the tab? So maybe you can at least tell you guys. where to find it.
Yes, so basically it's a JPanel and it implements our Webswing file chooser provider interface. And it has a few methods I will show. File chooser provider. So it's basically a simple interface. There are some things you need to implement, like set current directory or set selected file, get selected file and stuff. So you need to do some coding, but it's not really very hard. Request from one of our customers. So
I think the this example here in the demo is the best place to start. But
yep.
There is also a documentation on our webpage to get more information about this. Okay, I hope this answered the question, and let's see if we have any other. Yeah, we have the last one here. What about resource consumption of the fast serialization? I would say it will be same or better as protobuf, but essentially the resource consumption is I think the main reason why our serialization is faster is due to how we handle the byte arrays, or how we encode byte arrays, because some of our messages is kind of like an embedded message, where we have a message that contains another encoded message internally. And with protobufs, I think there was quite a lot of copying of buffers internally, and therefore I think even the resource consumption with our fast serialization will be better, because we have optimized this. Okay, one more question.
No more questions, yes.
Yeah, one more. There was one
okay.
appeared at the top. I just noticed. Can you explain how the migration framework works? Is it all configuration, or is code implementation necessary in both the legacy Swing app and or the new Angular app? If you're referring to this component migration that I described, or that I gave a little bit of an update, it's both actually. So there will be always some code needed, but the main focus of the component migration is to minimize the impact on the business code. Because what we do, we try to do this component migration. So we keep the component tree the same, and we're just replacing the way of the rendering by a web-based web components. So it's almost comparable to what React is doing, but it's client server. So the reconciliation is happening on the server side, and the updates are being sent to the browser. Or maybe it's also similar to Vaadin, but with Vaadin you have to create this new all the component structure, and with WebSwing you keep the component structure and only map the renderer part from the web components. But if you want like more details to this, I recommend you to have a look at our last year's webinar, where we had a demo that described this exact thing in much more detail. It should be on our YouTube channel, I think. Yeah, okay. So I think that's all questions are answered.
I have one comment, maybe. We had this question on the beginning. Have you already experimented with migration components introduced and released in Webswing version 23.2? And many of you answered no. So if there is any barrier to start, like you would need some introduction, some technical help, whatever from us, then please do not hesitate to contact us. We are happy to help on individual calls. That's all.
All right, cool. I think we can conclude it, and thank you everyone for joining our webinar, and see you in the next one.
See you in the next one. Have a good day.
Bye.
Bye.
Bye-bye.